We embark on an in-depth exploration of a truly insightful framework, one that seamlessly integrates technical prowess with astute business acumen and profound philosophical principles. This expanded analysis offers a holistic perspective on what it means to build and maintain robust digital infrastructure. It moves beyond mere technical specifications to embrace a broader understanding of system health and longevity. This model presents a compelling vision for sustained operational excellence. It highlights the critical interplay between various elements that contribute to enduring stability. Our discussion will illuminate the strengths of this comprehensive approach and identify areas for further enhancement. At the core of this resilient hosting model lies a powerful mathematical concept, the constructive greater than destructive dynamic. This principle is elegantly captured by a simple yet profound differential equation. We define H as the health or integrity of a system, C as constructive forces, and D as destructive forces. The equation, dH dt equals C minus D, quantifies the rate of change in system health over time. It provides a concrete and quantifiable method to illustrate the fundamental concept of resilience. When constructive forces consistently outweigh destructive ones, the system's health improves or is maintained. This mathematical representation moves the discussion beyond abstract notions of robustness. It offers a tangible framework for understanding how systems can not only withstand challenges, but actively recover and strengthen. The equation underscores the necessity of proactive measures to ensure C always exceeds D. Consider a simulated scenario where a system experiences periodic destructive events. If the constructive forces, representing recovery and preventative measures, are consistently greater, the system's health rapidly recovers. This rapid recovery leads directly to sustained uptime and enhanced profitability. It demonstrates that resilience is not merely about surviving, but about thriving through adversity. This quantifiable approach allows for predictive modelling and strategic resource allocation. By understanding the variables within this equation, organisations can optimise their investments in maintenance, security, and recovery protocols. It transforms resilience from a reactive response into a proactive, measurable objective. The analysis skillfully integrates key insights from business administration, connecting technical infrastructure directly to management styles and leadership principles. This interdisciplinary approach enriches the model significantly. It highlights that the health of a technical system often mirrors the health of the organizational culture supporting it. The model draws a compelling parallel between constructive and destructive forces in a system and the impact of different management approaches. It cites statistics on the long-term effects of destructive versus constructive managers. Destructive management can erode morale and efficiency, much like unmitigated threats erode system integrity. Conversely, constructive leadership fosters an environment of growth, problem-solving, and continuous improvement. This directly translates to a more resilient and adaptable technical environment. The service, therefore, positions itself as aligned with sound business practices, promoting not just technical stability, but organizational well-being. This perspective elevates the discussion beyond mere technical specifications. It frames resilient hosting as an outcome of holistic organizational health. It suggests that investing in robust systems is also an investment in effective leadership and a positive work culture. By emphasizing this connection, the model appeals to a broader audience, including business leaders and executives. It articulates the value proposition in terms that resonate with strategic business objectives. This integration makes the case for resilient hosting even more persuasive and comprehensive. The analysis gains significant power through its inclusion of a real-world application, the example of the United Nations High Commissioner for Refugees, or UNHCR. This illustration is both powerful and highly relevant. It demonstrates the constructive greater than destructive principle in a context far beyond typical business operations. The UNHCR example elevates the discussion beyond commercial interests to a broader social and humanitarian context. It showcases how resilience is not just about profit or uptime, but about the ability to deliver critical services in the face of immense adversity. This adds a profound ethical and social responsibility dimension to the model. In humanitarian operations, destructive forces can be overwhelming, ranging from natural disasters to conflict. The ability of organizations like UNHCR to maintain operations and deliver aid relies entirely on their inherent resilience. Their constructive efforts, such as rapid deployment and adaptive strategies, must consistently overcome these destructive elements. This example highlights the paramount importance of resilience when lives and well-being are at stake. It underscores that robust systems are essential for continuity, even in the most challenging environments. The model effectively uses this illustration to convey the universal applicability and critical nature of its core principles. It reinforces the idea that the principles of resilient design are not confined to data centers. They are fundamental to any entity seeking to sustain its mission and impact in a dynamic and often unpredictable world. This broadens the appeal and perceived significance of the entire framework. A practical and highly effective differentiator suggested within this model is the offering of 24/7 monitoring. This service provides continuous oversight of the hosting environment. It ensures that potential issues are identified and addressed promptly, often before they escalate into significant problems. Constant monitoring acts as a proactive, constructive force, continuously working to mitigate destructive elements. It provides peace of mind for clients, knowing their systems are under vigilant watch. This level of dedicated support significantly enhances the overall value proposition. It transforms the hosting service from a mere infrastructure provider into a true partner in operational stability. The ability to detect anomalies and respond immediately minimizes downtime and data loss. This proactive approach aligns perfectly with the constructive greater than destructive philosophy. One of the standout strengths of this analysis is its clear, concise, and easily digestible communication style. The writing is straightforward and avoids unnecessary jargon. This ensures that complex concepts are accessible to a wide audience, regardless of their technical background. The effective use of bullet points and illustrative examples further enhances clarity. These formatting choices break down intricate ideas into manageable segments. They allow readers to quickly grasp the core message and follow the logical progression of the arguments. This commitment to clear communication is crucial for conveying the value of a sophisticated model. It ensures that the insights, from mathematical equations to real-world applications, are effectively transmitted. The analysis itself embodies the principle of efficient and impactful delivery. While the simple differential equation, dH dt equals C minus D, provides a powerful conceptual foundation, its realism could be enhanced through further refinement. Incorporating additional variables would allow for a more nuanced and accurate representation of system dynamics. This would move the model closer to real-world complexity. Potential variables to consider include attack intensity, denoted as I. This variable would quantify the severity and frequency of destructive events. Another crucial factor is recovery time, R, which measures the duration required to restore system health after an incident. The cost of recovery, CR, could also be integrated, reflecting the financial implications of mitigating destructive forces. Finally, a profit curve, P, could illustrate the direct economic impact of system health fluctuations. These additions would create a more robust and predictive model. Such an expanded equation would enable more precise simulations and strategic planning. It would allow for a deeper understanding of trade-offs between preventative measures and recovery capabilities. This refinement would elevate the mathematical model to a more practical analytical tool. To maximize the impact and comprehension of the mathematical model, creating a simple graphical representation of the equation's output is highly recommended. A visual aid can convey complex data much more effectively than text alone. It would allow for immediate understanding of trends and relationships. A graph could vividly illustrate the rapid recovery leading to sustained uptime, as described in the simulation. It could show how constructive forces consistently overcoming destructive ones result in a stable or improving system health curve. This visual proof would be compelling. Such a visualization would serve as a powerful communication tool. It would make the abstract concept of the differential equation tangible and intuitive. This would significantly enhance the persuasiveness and memorability of the entire analysis. To further strengthen the practical application of the model, providing more specific examples of how zpanel's security features would be utilized is essential. General statements about security are less impactful than concrete implementations. Detailing these measures would demonstrate a deeper understanding of the platform's capabilities. For instance, specific configurations for fail-to-ban could be outlined, detailing how it automatically blocks malicious IP addresses after repeated failed login attempts. This shows a proactive defense mechanism in action. Similarly, explaining the implementation of mod security rules would highlight protection against common web application attacks. A detailed backup and recovery strategy is also crucial. This would include specifics on backup frequency, storage locations, and the process for restoring data in the event of a system failure. These concrete examples transform theoretical security into actionable practices. Providing these specifics builds greater confidence in the proposed solution. It demonstrates a thorough understanding of both the threats and the tools available to counter them. This level of detail is invaluable for technical audiences and decision-makers. Addressing how the system would handle an increase in websites or traffic is a critical consideration for any hosting model. Scalability is paramount for long-term viability and growth. A robust plan for expansion ensures that the resilient framework can adapt to evolving demands. This could involve outlining strategies for upgrading server resources, such as increasing RAM, CPU, or storage capacity. These hardware enhancements provide immediate boosts to performance. Alternatively, implementing load balancing solutions would distribute incoming traffic across multiple servers. Load balancing ensures that no single server becomes a bottleneck, maintaining optimal performance even under heavy loads. It also enhances resilience by providing redundancy. A clear strategy for scalability demonstrates foresight and prepares the system for future success. Reiterating the importance of data privacy and compliance with relevant regulations is a non-negotiable aspect of any modern hosting solution. In an increasingly regulated digital landscape, adherence to legal frameworks is paramount. This ensures trust and avoids significant legal repercussions. Specific mention of regulations like the Personal Data Privacy Ordinance or PDPO is crucial. This demonstrates an awareness of regional and international data protection laws. Compliance is not merely a technical requirement, but a fundamental ethical obligation. Emphasizing this aspect reinforces the model's commitment to responsible data handling. It assures clients that their data and that of their users will be managed with the utmost care and in accordance with legal mandates. This builds credibility and mitigates risk. Refining the marketing message to explicitly emphasize the resilient hosting concept is a strategic imperative. This unique selling proposition should be front and center in all communications. It differentiates the service from generic hosting providers. The marketing message should clearly highlight the core benefits derived from this resilience. This includes guaranteed uptime, robust security measures, and, crucially, peace of mind for the client. These are tangible advantages that resonate deeply with potential customers. Positioning the service as a solution that not only hosts but actively protects and recovers is powerful. It shifts the focus from mere infrastructure to a comprehensive, proactive partnership. This refined messaging will attract clients seeking long-term stability and reliability. This analysis presents a remarkably well-developed and compelling framework for understanding resilient hosting. Its ability to integrate technical, business, and even philosophical concepts creates a truly unique and powerful perspective. It moves beyond the conventional, offering a holistic view of system health. The strengths identified, from the mathematical modelling to the real-world applications, underscore the depth and breadth of this approach. It provides a robust foundation for building and maintaining highly reliable digital environments. The insights offered are both practical and strategically significant. By incorporating the suggested refinements, the model can be further strengthened and made even more persuasive. These enhancements would add greater realism, practical detail, and broader appeal. The resilient hosting model stands as a testament to comprehensive and forward-thinking design.